Yeah, so hello and good afternoon, everyone. It's great to be here at ContainerDays and to see so many of you even 40 minutes before the beer, so thanks to be here. Joel and I are excited to share our latest development and experiences and learnings about our development of 5G mobile core. But we want, of course, to speak about how we are transitioning from spreadsheet to everything as a code. Presentation. I'm Jéremy Weber, working as a DevOps engineer at Swisscom.
And I'm Joel Studler. Happy to be here as well. Welcome from my side. Thanks for being here. We both work for Swisscom. So Swisscom is Switzerland's biggest telco and IT provider. We both work in the team that modernizes basically 5G in the 5G core area, which is being transformed to cloud native. So to set the scene a little, to differentiate the terms, so 5G for a telco, it means basically two things. One side of things is the rollout of the antennas, which is the radio access network. And the other thing is the core, where we also modernize the whole technology under the hood, and not just the standard. So we really focus on the 5G core part in this presentation. So let me dig right into it with a little demo. So this is a 5G-enabled device connected to our lab 5G core. You can see the antenna, there is reception, but there is no 5G sign, so we are offline currently. The reason for that is that we just very recently, 17 minutes ago, we redeployed one centerpiece of this 5G core, so the PCG. That's the namespace PCG802 is basically the packet core gateway. So that's the data plane, the actual router that is running within the 5G core. It takes several minutes to redeploy it. So let's hope that at the end of this session, when we come back to the demo, that we will see that it works again. So what does 5G core mean, or what does a network mobile core mean? Let me introduce you the history of it very briefly. So it all started with 2G, which was the first mainstream adoption of mobile networking. Back then we had bare metal hosts, so servers in racks, and spreadsheets for configuration management, so Excel sheets. Then 3G came along. It was still running on bare metal, and spreadsheets were extended by scripts. You can imagine Visual Basic or some Python scripts reading an Excel file, like proper automation, right? Then a few years later, 4G came along. So there we had a first step of virtualization from bare metal to VMs, basically a box move. So not a lot of innovation, but still first steps in virtualization. And spreadsheets and scripts were extended with some more sophisticated automation like Ansible. And now we are currently building the 5G cores all over the world. So that's the next big step. The next level of virtualization with containers and Kubernetes, and also the next step of configuration management, basically infrastructure as code, GitOps, and so on. And the future, we don't know what it brings. It's probably going to be called 6G, but we don't know what technology is going to be used. So I won't throw buzzwords at you at this point in time. So on this slide, you can see two very important evolutions. So one is really the virtualization from bare metal to containers, which probably you all know because you're here at ContainerDays, so you know the history a bit, I assume. And the second one is really what we're going to talk about is from spreadsheets to something more sophisticated infrastructure as code, basically. So let me talk about Kubernetes. So every vendor knows today Kubernetes is the next infrastructure layer. It's clear they need to migrate and so on. But what's very unclear still for many software and hardware vendors is how to master it. We currently see two ways of doing that. So the first way is from the left to the middle. where you basically start Kubernetes native. So you adapt all the cloud native concepts like CRDs, Kubernetes operators. You use all the Kubernetes native tools, and only later in the story or in the development, you add the features that your legacy product have. I call this the Kubernetes first approach, where you start with Kubernetes in mind at the very beginning. Examples of this are Nefio, a project introduced by Jéremy later on. The free 5G core, it's an open source implementation of 5G core, or tools like Cert Manager, which are basically built for Kubernetes, right? So to summarize, you start with Kubernetes in mind, you have a small feature set at the beginning, but after some time, you add feature parity. The other way we see is that you basically take the existing product and you put it into containers. So you have all the features at the beginning, and only then you will add Kubernetes integration. I call this the features first approach. You containerize the existing product and you're done because you have feature parity. But eventually you're going to need to evolve and add cloud nativeness to it. Examples of that are the 5G core we're working with, where you have, for instance, NETCOM, which is a not so cloud native protocol for configuring. Also, this will be introduced later on by Jéremy. Yes, and I can imagine you know many examples of this path of containerizing a product that is not built for cloud native. So to summarize, you start with all the features, but only later you add Kubernetes nativeness.
Yeah, thank you. So there is a journey for the vendor, but we think there is as well a journey for us, for Telco. That's why we have Telco from Telco to TECO. What does it mean? It means we need to, in our opinion, we need to simplify things. We need to simplify our product, we need to simplify our processes, and thus as well helping us to reduce cost. Of course, cloud nativeness, it's maybe a bit of a buzzword, but we really think it's a paradigm shift in this world. We need to think differently and not to think about telco-grade application or telco-grade whatever. And everything that can fail will fail, and this is something we are not so familiar with in the telco world. Automation, yeah, of course. We need to increase the releases cycle, not 2 times a year, but much faster. And as well, this will help us avoid bringing too many changes at once. But as well, reduce toil, so enable us to have more time for meaningful and more interesting work to do. And of course, people and culture. Like the talk this morning from Sebastian, really people are the central piece of this journey. If people doesn't change, the processes will not change, and we think it will. The whole journey will fail, and we need to as well embrace the failure. So let's talk a bit about what we have today. Before this, I would like to introduce you to NetConf. Maybe it's not that well known in IT world. So NetConf is a network configuration protocol. It's defined in an RFC. It's SSH and XML based. And in telco world, it's really the de facto standard. You have it everywhere, as well from vendor side and from the telco side. Everyone wants it. But for us, it really brings challenges because it's a box-centric approach. You don't configure microservices, but you configure really an entire entity. And even though there is Kubernetes operators that exist to configure NetConf, it's really not cloud native, and that really hurt us. Okay, what about our journey? It really all started with the LLD as code. LLD stands for low-level design. You can see it as it's similar to a blueprint. That's where we store all our IPs or the network's name and basically everything. And we designed it as, you see an Ansible inventory. At the bottom, you have the host, so the Kubernetes clusters, stored into groups, being the place where these Kubernetes clusters are stored, are deployed. And as well the environment. Is it a prod or a dev cluster? And on the right side, you see as well a small snippet of this LLD, where we store all the virtual IPs that we have. why it mattered. It sounds like not too much, but for us it matters a lot because it was the first time we really have everything as in one central place, a version control that can be reused by templates, for example, Jinja templates. And there we can create netconf configuration based on the IPLLD. So it really improved the quality, improved the errors rate, because then you don't copy-paste config files from different environments and change the, the values by hand. Now it's done through Ansible playbook based on an LLD, which is version control and accessible by everyone. And as well, this brings a lot with automation. We reduce toil again. So what's about our journey? So we had this LLD, and then we had to deploy our network function. We want everything as everything to be in Git, so we use the Flux CD. Everything is stored in our GitLab repo, and artifacts are stored in JFrog. Then we need to bring these artifacts in an automatic way. So our software vendor has a software gateway, and we've built a Jenkins pipeline to fetch automatically this software and store it in our Artifactory. Then the configuration. The network function after deployment, they are not yet ready. They need to be configured. And they need to be configured, guess what, with netconf. And that's why we have an Ansible playbook that will read secrets from Vault, for example, passwords, and push the netconf automatically to the network functions. As well, you know we don't store secrets in Git. That's why we use external secrets operator to fetch the secrets for the value of the secret in Vault and push the secret. If you don't see anything in your cluster, it's a bit useless. So we've built as well Thanos and Loki to have all the metrics and the logs stored for a long period of time. And we have the entire monitoring stack with Grafana, Prometheus, and the alerting together with Opgeny. Then we have some integration system we worked on, different system within Swisscom. And the most important one, we are currently working heavily on testing, and we put more currently TestCube as a central piece for our testing. Okay, that's about today. What comes tomorrow?
Yeah, thank you much. I will now talk about how we envision the future of the automation in our 5G core. We really think that Kubernetes operators are going to help us a lot in automating the challenges we have. So, yeah, it's maybe a bit funny at this to talk about Kubernetes operators and explain what it is at the conference hosted by a company that embraced it even before it existed. But nevertheless, I'm going to talk about it. So there are three components. CRDs are used as API extensions, so custom resource definitions. You basically have a schema. You extend the existing Kubernetes API with whatever you want. The second step is instantiation of these schemas, of these CRDs. It's called custom resources. And then the third important part is the actual business logic, which is your operator, normally written in Golang and deployed on the cluster itself. And you tell the operator whatever you want it to do. So it could be lifecycle tasks, backup tasks, or anything else that could be self-healing. So why do we think Kubernetes operators are relevant? First of all, Kubernetes is very well established. So the tooling, like kubectl, like Argo CD, Flux, it's almost every DevOps engineer on the planet should know it by now. The reconcile loop, we really think that by design, Kubernetes operators bring in a different pattern compared to traditional CI/CD tools like Ansible or Jenkins, which are more fire and forget, and you need to manage the states somehow, or the actual the diff between desired and actual state. And the third thing, again, is community. So Kubernetes, as well as KubeBuilder, the framework which you normally use for building operators, has a very vivid community. Or in other words, just like computers stepped in for human computers in the 1950s, operators are now stepping in for human operators, helping out with the hard and boring work. So let me now talk about a few use cases of Kubernetes operators in the 5G core. So you've seen the drawing shown by Jéremy, and I will also set the scene with these elements. So the first use case is the future of NETCOM. So you've seen the pipeline, which is basically a Jenkins pipeline that triggers an Ansible playbook that reads data from Git and then pushes it down to the network functions or to the application. So that's how it was yesterday, or how it is currently. And in the future, we envision that we would have a Kubernetes operator, the NETCOM operator. So there are open source projects that actually take care of that already. And we would push down the configuration through Flux GitOps, and the configuration would be stored in custom resources. So it doesn't make it cloud native in a way, so it's still static configuration in Git at the very beginning, but it will help us moving configuration management to a more cloud native approach. So the advantages we see is reconciliation. So if we have a config change, we need to let Ansible know to deploy it. In case of Kubernetes, it would automatically reconcile through the chain, so Flux and then the operator responsible for netconf. And the second advantage we see is that it's contained within the cluster, so everything that is related to the app running on the cluster is contained in the cluster itself. The second use case is testing. So that's already being implemented right now. So yesterday we had, again, this Ansible, GitOps, Jenkins pipeline, which would trigger tests in various testing tools. So that could be Telco specific tools or chaos engineering tools or whatever other tools. They could run on a cluster or outside the Kubernetes cluster. And in the future, or now, we again have the GitOps pipeline through Git and Flux, which would deploy test cases to the Kubernetes clusters with schedules or triggers. And then we have the TestCube operator. TestCube is a testing framework. I think it's the only cloud-native testing framework on the landscape that would actually read these tests and then trigger the external tools accordingly. The advantages it's again that it's integrated in the Kubernetes cluster itself, so it's self-contained, so to say. And with TestCube, we get some kind of single pane of glass with all the testing that is going on the cluster and on the entire 5G core. The third use case is about static routes. So since the 5G core is not only a bunch of microservices and APIs, it's also actual routers that forward data. And there we have some specific requirements to networking, and one of them is static routes, where we basically need to let the Kubernetes node know where to go for certain static routes. The way we do this currently is we again have Jenkins triggering Ansible, reading the source of truth from Git, and then pushing the routes through SSH to the nodes. In the future, we imagine, again, GitOps through Flux, and Flux would basically deploy two components. The first one is the static routes operator. There are some open source projects as well out there, which is deployed as a daemon set, so it's running on all the nodes. And then we would have static route custom resources, which would be read by these pods, and then enforce the static routes on the node. The advantage we see there is it's self-healing. So if for whatever reason a route goes missing on a node, it could be a network hiccup, or it could be someone tampering with the routes on the node. It would recover automatically. And the second advantage is scaling out the node pool would automatically scale out the daemon set, which would automatically apply the routes. Then the last use case I want to talk about is certificate management. So in the past, we had, again, the entire Jenkins Ansible GitOps pipeline, which would integrate with our Swisscom internal PKI. So Ansible would basically generate TLS certificates, sign them on the internal PKI, and then write the secrets down, the TLS secrets down to the cluster. Sorry. We also have Flux in the picture here for basically deploying the ingress resources and the application manifests that would then consume these secrets. What we see in the future is that the Flux part is mostly unchanged, except that we add certificates of Cert Manager. So we would basically introduce Cert Manager on the cluster. We have our own plugin that integrates into Swisscom's PKI, and Cert Manager would basically reconcile these certificates and then write the secrets to the cluster again. So they can be consumed by either the ingress, which could be Nginx, or the app itself, if used by the app. Yes, that's already implemented, and it works very smoothly. We have an internal community also of developers, and someone already wrote this plugin for Cert Manager, so we could reuse it internally. That's very nice. Advantages we see is by using Cert Manager, we automatically have cert rotation covered, so we don't need to take care of expiring certificates, re-trigger some pipeline manually or any of that, or automating it. It's already there because Cert Manager automatically renews certificates. And the second topic is about security. So in the case with Ansible, with an external tool generating a certificate, we transport the private key through, if we assume Kubernetes, the Kubernetes cluster is the trust boundary, we cross one trust boundary with transporting some very secret information. And if it's contained within the cluster, we don't cross this trust boundary, which is a security advantage.
Yeah. So you all talked about a lot about these operators, but then you may ask, what does it mean for this 5G core? As you see, we see at the bottom all these operators doing one specific task. Can be IPAM, can be netconf, can be whatever. And what we envision is, on top of these operators, we will have specific CNF operators that knows, okay, this specific CNF, cloud native network function, needs these specific requirements. And these operators will know what this CNF needs. And on top, we can continue, because we are not building simply one container, one service. We're building multiple services. And the idea is to build an entire stack of operators that all talk to each other downwards, and each of them has dedicated responsibility and knows exactly what he needs to do for a specific task. So at the end, we have a business intent, very simple, not necessarily simple, but a business intent in YAML format that can be pushed to a management cluster, and it will be propagated down through all these operators, hopefully fully automated and without human intervention. And actually, this idea doesn't come entirely from us. It comes from this Nephew project. It's a Linux Foundation project, where basically it's an intent automation for Telco. And we took this idea from them, and for now we will participate as well in their community. But I think it's time to check our demo, if everything went fine.
Let's check, yeah. So hopefully everything works again. So on the cell phone that is still connected to the RAN, we can now see the 5G icon, which is very nice. We have Google that loaded, so let's hope for the best. So we can also load ContainerDays.io. So it looks like we're back online. Pretty sure we are online. Let's go back to the cluster and see. So we know that the namespace was redeployed, right? That's it's 40 minutes now. Let's check in this namespace the Helm releases. So with Flux, the resource, the custom resource used for deploying Helm release is called Helm release. I think that makes sense. So we can see the only Helm release in that namespace was reconciled successfully, so that's nice. And also, if we get all the pods, we can see, so there are plenty of pods running, completed, so it looks very, very, very good. If we look at Jenkins, we can also, let's refresh the page. So remember, the namespace was created 14 minutes ago, which would be around 5 past, if I'm not mistaken. And then the actual pipeline, so you've seen the trigger that as soon as Flux reconciled the Helm release, there would be a trigger to Jenkins. And we can see that happened at 5:30. So at 5:30, Jenkins was informed and basically did this netconf application of the configuration on the actual network function. So that worked. It went through smoothly. And now we're back online. And also, we have some end-to-end testing implemented. So we can see 5 minutes ago, the last test was triggered, which would probably be the one that was also triggered as soon as the network function is ready. So there it's not sufficient to wait for the Helm release being ready because the configuration is not yet applied, right? You can imagine applying the Helm release would only put a box into a rack and without any configuration. And that's how netconf interferes with cloud nativeness. And you can see, so it's maybe, let me try to zoom in. So the test was running for some time, and then we get back some JSON report from the testing tool we're using. The test that we executed here is quite similar to what I did in the UI of the Android device, basically trying to open some website, and it's really an end-to-end test, smoke test. Yes, I think that's pretty much what we can show you. So we've shown you that during our demo, we were able to redeploy one entire CNF network function. So the actual router, we deployed it during the demo, and using Flux and Jenkins, Ansible, Test Cube, we were actually able to automate it end to end. So with that, I leave you the stage.
Yeah, thank you. So for the final words, the takeaway before the beer. We'd like to give some words about what to avoid. So you should avoid the building workarounds because of some limitation. Try to talk to your vendor or whatever software and try to lift this limitation from the ground up. For example, this sourcing pipeline we've built, it should be removed, and our vendor should push the software directly to our repositories. Try to avoid defining everything in advance. Of course, you need to plan a bit, but we think you need to learn fast and fail fast to build something great out of it. Don't confuse scripting with automation. Reading an Excel sheet with a Python script to apply a config is maybe not the best. Automation is much more than this. And what you should aim to, embrace cloud native, participate and contribute to CNCF project. It can be as simple as raising an issue with some bug or some documentation which is not clear. We are part of a community, and it's how it works. You should extend existing solution in a non-interfering way. So don't break anything, and operators are here for specific functionality. Contact your vendors, creators. We think it's really both ways communication, and push them to be cloud native. And work in increment way, not build everything at once and then realize it's not exactly what's the purpose, but really build incremental and solve issues step by step. last words. We really think like Kubernetes and operators are today the de facto standard and should be extensively used. If it's not in Git, it's only a rumor. So put everything in Git, and there's no question about it. If it's it will be applied by the operators anyway. And ensure your product follows the cloud native standards. And like I said, yeah, contribute to the community. For example, Swisscom will be soon part of Nefio, and that will be the end of the talk. Thank you very much.
Thank you very much.
Thank you guys so much for also being on the last spot, which isn't always easy. So we're going to do some questions. I got some questions in via Slido, so let's do the first one. Actually, also the second one. So have you considered replacing the Jenkins implementation with the likes of Argo CD and or Flux?
Replacing Jenkins. Yeah, so Jenkins was the go-to tool for CI/CD at Swisscom. So that was a corporate policy basically. But so yeah, so we're certainly looking at replacing it in a cloud native way and hopefully on Kubernetes itself. So a few words on Flux versus Argo. So the Helm charts we're getting from the vendor, they're heavy. They're like multiple megabytes, or yeah, even more, I think. Yeah, they're really huge. And they're making extensive use of Helm hooks. And with Helm hooks, as you may know, since Argo CD is not using Argo CD is only using the Helm templating part of Helm, as opposed to Flux, which uses the whole chain. So you can imagine, compared to the command line, Flux would do a kubectl a Helm install, whereas Argo CD would do a Helm template and then pipe it and then do a kubectl apply. So you would only Argo CD would only get the templated result of the Helm chart and then apply it to the cluster. So in this regard, we cannot use Argo CD, unfortunately. When it comes to Jenkins, yes, we're pretty much working on moving as much as possible to the cluster itself and using tools like Tekton or Argo workflows. We don't know yet. Yeah.
Good. And then the last question is, I think it's a good one. Do you engage with other telcos that face the same challenges in upgrading their 5G cores?
Yeah, we are definitely in talk with some other telcos. They have the same challenges, same processes challenges as well. For that shift, yeah, we know about it. It's a bit different area. It's more infrastructure. It's not. We have a dedicated team at Swisscom handling infrastructure, but we are definitely in talk with other telcos and trying to push our vendor to go in the right way.
Great. Thank you for answering all the questions, and thank you to the audience for putting all the questions into Slido. And this was the last talk of the day on K4, so you can all go outside now to enjoy the beers.